Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming. This series is brought to you by Teagasc in collaboration with Dairy Sustainability Ireland and the National Rural Network and Food Drink Ireland SkillNet. So today we're going to be talking about the carbon footprint of dairy farms along the Atlantic coast of Europe. And the Dairy for Future project aims to increase the competitiveness, sustainability and resilience of dairy farms in the Atlantic area. And I'm delighted to be joined by Marion Sorley, who's a research technician with Teagasc, who was involved with this project. The project is coming near its end. And later on, we'll be joined by Dr. James Humphreys, who's Principal Research Officer with Teagasc in Moore Park, who'll be helping us out with the questions. Good morning, Marion.
Hi, Mark. Hi, Pat.
And good morning to Pat. How are you doing, Pat?
Great. Not a problem.
You're going to help us with questions later on. So, Marion, you're very welcome. This, I believe, is your first time to the Signpost webinar.
It is.
Tell us a little bit about. Can you tell us a little bit about the work that you're doing down in with Teagasc in Solihull-based research, I imagine?
Yeah, it is. It is. So, yeah, at the moment I'm working on the LowCam project that's based on in Solihull, and it's looking to reduce carbon and ammonia emissions. But today's talk, however, will be on the Dairy for the Future project. And as I'll explain in the talk, we'll be looking at a number of different countries and regions along the Atlantic area in Europe, and looking at a big data set of dairy farms from those regions and their carbon footprints.
No, it's great to have you on the webinar this morning, Marion, and to talk to us about those regional differences around carbon footprints along the Atlantic coast. So Marion, I'm going to hand over to you, and we'll talk to you after your presentation.
Great, thanks, Mark. Today I'll be talking to you about the carbon footprints of dairy farms along the Atlantic coast of Europe. Now, the Atlantic area, you'll see they're highlighted in blue, stretches all the way from Scotland in the north down to Portugal in the south and the Azores Islands. What's unique about the Atlantic area is that it has a high rainfall suitable for agriculture, with varying degrees of evapotranspiration. And with this, we get a mix of systems down in the south, in Portugal and Spain. You tend to see more confinement house systems. And as we go up north, we see more mixed or pasture-based systems. Now, these countries in the Atlantic area, the countries themselves produce about 36% of Europe's milk production. So they're quite important for milk production. But you'll notice that Ireland is the only country that's included as a whole country in the Atlantic area. But like in France, for example, the Brittany, Pays de la Loire, and Normandy actually produce about 55% of France's milk production. And in Spain, Galicia produces 39% of Spain's milk production. So very important regions. And we have recruited just over 100 commercial pilot dairy farms across these regions. And with that, I'd like to say a huge thank you to the Dairy for the Future farmers who opened up their farms to us and generously gave up their time to fill out those monthly recording sheets and gave us very detailed information about their farms. So a huge thank you to them. So we also had 10 experimental dairy farms, one of them being Solihull Research Dairy Farm in County Tipperary. James Humphreys leads the Irish component of the study, and also leads the work package on environmental assessment. And the project itself is coordinated by André Legal from the French Livestock Institute. And you'll see here, we have partners from all of the different regions. Idel, Shruk, CAFRI, AHDB, NICA, 2 universities from Portugal. So there's a lot of work gone into this and a lot of different expertise there. And it's funded by the Interreg Atlantic Area Program. Here I'm showing you the per capita greenhouse gas emissions in these countries we're looking at in the Atlantic area. And you can see here Ireland sticks out quite a bit with the highest emissions per capita here, and a big proportion of them coming from agriculture, 34%. This is for the year 2019. It's more than 3 times the average, 11% for the EU and 27 in UK. So what are we doing to tackle these emissions? These are the policies for reducing our greenhouse gas emissions from these countries. Our target reduction in Ireland is 22 to 30%, one of the more ambitious targets, followed then on by the UK and Spain and France on 18 and Portugal on 11, but our baseline year then for Ireland is 2018. And what's notable about 2018, it was quite a dry year. We had an increase in dairy cow numbers, increase in fertilizer, nitrogen use, their peak in emissions. We had varying baseline years then, as you can see down the table for the other regions, earlier baseline years. Targeted measures then, we see a common theme of fertilizer, nitrogen, manure management. Now that's really about reducing our fertilizer nitrogen use, reducing the amount, moving towards use of legumes such as white clover to biologically fix nitrogen, making more use of our slurry in our manure management. We're talking about low emission slurry spreading, covering our slurry storage. And in Spain, for example, it's looking at that slurry storage, but also solid liquid separation for more practical application. And then we have other strategies like improving our genetic merit, common to Ireland and Portugal. It's about increasing the longevity of our cows, our milk how productive they are, and then other measures then like agroforestry, bioenergy. So what are our aims and objectives? It's a study of carbon footprints of milk from these dairy farms, and the aim is to lower the greenhouse gas emissions from these commercial dairy farms. And to do that, we needed a diverse range of practices and systems, and to best identify identify the best practices to do that. And we know we needed to identify specific solutions for the different farming systems, whether they're pasture-based or indoors, which I'll expand on later on as well. But we also looked at the economic and social implications, which are quite important as well. But today I'll just be talking about the carbon footprints. So how do we calculate a carbon footprint? Well, we know that we know that different activities on farms create emissions such as spreading fertilizer, storing manure, cows defecating at pasture, and we total up all these emissions for a farm, and then we can express them per kilo of milk or per hectare of land. These are different metrics we use. And what I mean by per kilo of milk, it's the unit we use is fat and protein corrected milk. So it's a unit standardized to 4% fat and 3.3% protein. And the tool we use is life cycle assessment, and it accounts not only for the on-farm emissions, but also the off-farm emissions from our inputs such as fertilizer, fuel and concentrate coming in onto the farm. So it really takes into account all the emissions associated with the production of milk up to the farm gate boundary. Now we used an adapted version of the Moorpark model designed by Donal O'Brien, and we had to adapt it to account for the different conditions in these different regions. So these are the different regions we're going to be looking at. Ireland, Northern Ireland, Great Britain, France, Galicia, and Basque Country in Spain, and Portugal. Now, we have about 10 farms for each region, give or take. We have 20 farms from Portugal, and we needed to select more progressive farms. The data collection was really quite intensive, and we needed to ensure that we could get the data from these farms. And we needed a diversity of systems, a wide range of practices. So they're not necessarily representative for each of these regions. These then is a table of some characteristics from these different regions, their mean averages for the farms for these regions. So if we look at stocking rate, first we hang around about 2.3, 2.2 livestock units per hectare. France there is the lowest at 1.51. There are three organic farms in the France sample, which bring it down. In Portugal, then we have very high stocking rate of 7.84. The Portuguese farms are all confinement systems, so it's quite an intensive system where a lot of the feed is brought in and manure is exported. And then if we look at the milk solids production, generally higher with the indoor systems, and we can already see here a trend with the age of first calving and the young stock and replacement rate percentages. Generally, when we increase our milk yields per cow, we tend to have higher age of first calving and greater replacement rates. And it's interesting to see that if you look at the differences between young stock and replacement rates, that it's generally about it's 3% right across the board. So we know that there is a room for improvement here. Then the next table, then we still got stocking rate there. We've got grazing time. So it's in percentage. It's the percentage of time that cows spend out grazing in the year, and it also takes into account the proportion of cows out grazing. So it's accounting for our calving patterns as well. Basque Country, there you see it's around 5% grazing. That's not because the average is across the farms is 5% grazing. It's we have a mixed system in that sample, but they're mostly house systems. And then if we look at the grazing time to concentrate, we know that generally, if you're increasing your grazing, we're showing a decrease in concentrate being bought in. We see that here on our next graph, with the decrease in grazing showing increase in concentrate use and milk yield, which we'll expand on later on in our carbon footprints. But we see in the Basque Country, there's over 3.5 ton of concentrate bought in per livestock unit. Over like 4 ton of concentrate and forages in the Portugal. So these are our confinement systems. And then if we look at fertilizer and nitrogen, highest is Ireland. It's really reflective of our grazing time, shows, I guess, our reliance on fertilizer nitrogen, and something that will show up too in the carbon footprints, which I'll show next. So these are our carbon footprints for the different regions, expressed in kilos of CO2 equivalents per kilo of fat and protein corrected milk. And we're not looking, we're seeing really a reflection of the systems used in each of these different regions. Ireland with our a big proportion, 17% of our emissions coming from fertilizer, compared to the confinement systems in Spain and Portugal, relying on concentrate and obviously a lot of manure storage with those confinement systems. Now here, I just wanted to show you this. These are all the farms that we're looking at today, and we have Ireland, Northern Ireland, Great Britain and France in shades of green and blue, and then Spain and Portugal in shades of orange and red. And what you see here is that there's no one country that's particularly low. There's a good variation in carbon footprints. You see even the lowest four there, they're all different regions. And we'll have a look at this later on again, but you see there's a big variation range in the carbon footprints, at about 0.9 to 2.5. So I just wanted to explain the three categories as well for our farm systems. Grazing is that this category is defined by more than 60% grazing throughout the year. So 60% of the time the cows are out, and again that's taking into account the proportion of cows as well that are out. The house system, then they're indoors all year around. And we see that reflected in our grazing times. These are the mean grazing times in the different systems. So 68% on average for the grazing system, 42 for the mixed, and of course 0 for the housed. And we have a good distribution. We're about half and half grazing mixed, and the other half housed. So it's you see, remember this graph. It's similar graph, but color coded to the different systems, and we see that generally the green tends to be on the further down on the left hand side, but we do have quite a variation. If you look at this farm here, SWE3 has it's way on the right, and that's actually an organic farm, so relatively low milk production, driving up their carbon footprint per kilo of milk. But otherwise, you'll see also like the three lowest farms, it's a grazing, a mixed, and a house system. So it's hard to say that one is better than the other. These are the average carbon footprints then, with the different activities highlighted from where the emissions are coming from. So in the blue we have enteric fermentation, methane emissions from enteric fermentation, and generally more house systems, the enteric methane goes down. Greater manure emissions then with house systems, same with concentrate, and greater fertilizer nitrogen emissions with the grazing systems. So I'll go on then to explain each of these categories. And first of all, we're looking at the methane emissions from enteric fermentation. And although the house systems have a higher replacement rate, a higher age at first calving, so they're having to carry more young stock to support their dairy herd. They are producing a lot more solids per cow, and they're feeding a lot more concentrate. And what we see with increased feeding of concentrate is actually less methane emissions per kilogram of dry matter intake. So that can make a difference. And the thing is, we can model that difference. So next, then we're looking at manure emissions, or emissions from manure management, and obviously the house systems here have have a big proportion of their emissions coming from manure management, and really the cows are spending a longer amount of time depositing manure into storage. So that's really where we see the emissions coming from. It's about the longevity, about the length of time of housing. But also we've seen here, it's about the type of storage as well. So the farm on the right has uncovered manure storage compared to the farm on the left, which has covered manure storage, and we can see what a difference that makes. These farms are similar in milk production, similar outputs. So the farm on the left has actually halved their emissions by ensuring that the slurry storage is covered. And you can imagine this is particularly important in warmer regions. So next, we're looking at concentrate emissions. Again, particularly important for the house systems that rely on a lot of concentrate feeding. And the averages for across the systems then, we're feeding almost 3 tons of livestock, 3 tons of concentrate per livestock unit in the house systems, compared then to the grazing at 837 kilos per livestock unit. But we found that it's not only the amount, but the type as well. And if we look here at these two farms, one is feeding a greater amount of concentrate, 5.4 ton, compared to the farm on the right, which is feeding 3.8 ton. Now they're feeding less, but their emissions are greater, and it's because the amount of soya in the diet. We know that soya has quite a high carbon footprint because of the deforestation that it goes to grow soya in South America and Brazil. Compared then to the farm on the left, which is using more locally produced concentrates with a low crude protein. So that's very important as well. And then next, we're looking at emissions from fertilizer. Particularly important for our grazing systems. We're quite reliant on fertilizer nitrogen. Our average there of 247 kilos of nitrogen per hectare, quite high. And really, I guess, grazing systems obviously rely on grass as the main fodder. So grass is quite, it's nitrogen loving kind of plant compared to the mixed and house systems, where their feed can mostly consist of maize, which is not as N reliant. But grass is important, obviously. In Ireland, it's a cheap feed, but we need to work on reducing our reliance, and we'll talk about that later on. But if we come to our summary then, so we have ambitious targets, reduction targets set for agriculture. We've seen that, like, in our emissions per capita, we have one of the highest, and a big proportion of that coming from agriculture. We need to at least cut that by 22%. And what's promising is that in the study, we've got a big range of carbon footprints, from 0.9 to 2.5 kilograms of CO2 per kilo of milk. Even within the Irish data set, there's a range of 1.4 to 1 of a carbon footprint. So there's considerable potential for lowering our emissions. In Ireland, we've seen we've got a heavy reliance on fertilizer nitrogen use. So we know we need to actually cut our use of fertilizer. We can use more clover in our swards, using that biologically fixed nitrogen to grow our grass instead. Research shows in Sorley that we can do that with the use of white clover and red clover. even cut out nitrogen completely. When we're using nitrogen, then to use more protected urea, we know protected urea cuts out greenhouse gas emissions and ammonia emissions. Manure management, then using the low emission slurry spreading to make use of our slurry also reduces ammonia emissions. As we saw, also it's a type of storage as well. Concentrate use, then it's about them. Also the type, it's something to be aware of, and especially in those house systems. And in enteric fermentation, then we're trying to improve the quality of our feed to get more milk for dry matter per kilo of dry matter intake. We're trying to improve our EBI as well to produce more efficient cows. And we've seen there that pasture-based systems tend to have lower carbon footprints, like the systems that we see in Ireland. So there's a whole lot of different aspects to this study, and I guess this was a snippet of that. And we've also looked at the carbon footprints using other metrics such as per hectare of land. We're also looking at other impact categories such as acidification, eutrophication, fossil fuel, and global land use. We're also looking at human edible feed conversion efficiency. So, how much of the cow's diet that we're feeding is actually human edible, and compared to the product that we get at the end, in this case, milk. And we're also looking at the economic and social impacts. So I'd like to end on acknowledging all the people involved in this project. It's a huge project. James Humphreys leads the environmental assessment work package, but we have partners there from France, Spain, Portugal, England, Scotland, and the collectors as well. Without them, we wouldn't be able to get this started together. So big shout out to them. Thanks for listening.
Thanks, Marion. Really enjoyed that presentation. I know you had lots of graphs, but you explained them so well. Those bar charts, I think, really tell a story about that profile of emissions. And one thing I just picked up on, you showed a slide there about the different, the concentrate, the difference between the different types of concentrates, the locally fed versus the soya. And I mean, is that being taken into account in general when we're doing life cycle analysis on farms, or is it specific to this project? Because it just seems to me that that could have huge implications for where people source their concentrate from.
Yeah. In some studies, yes, they don't actually include land use change emissions in their assessments, but I think more and more we are including them. And yeah, you're right, there is an important message to be had from that. Yeah, as you can see, it makes a huge difference.
We have James Humphreys is going to join us as well. James, welcome back. You were with us there a couple of weeks ago talking about red clover. And so James, you've been involved heavily in this project from an environmental perspective, Marion was saying.
Yeah, well, I was involved in setting it up and getting the funding and with the other partners getting the data collection, which was an absolutely huge task over 2 years, and an awful lot of people involved, and one common data set with 5 different languages and these type of problems. But I suppose, just going back to the question you asked Marion there about the concentrates, like it all depends on how we assess a carbon footprint. And the problem is there's a number of different metrics we could use. And like I suppose from a marketing point of view, if we're trying to sell a product and we want to know the global carbon footprint of that product, that's the metric we've used because it's the most common metric. And that takes into account the land use change in other countries and the impact that might have on concentrates. If we look at it within a national boundary, which is the national inventory approach, where we only look at emissions generated within the national boundary, that gives a different perspective. I hope I'm making sense now. That say if you're looking within the national boundary for Portugal, you wouldn't include concentrates imported from Brazil.
And that is the methodology that's used by the IPCC.
Yeah, so there's two different approaches. So, and again, keep it fairly simple for this presentation. We just stuck with the one approach.
Marion, you also showed a slide there, an interesting figure. I think, was it a Swedish farm that was organic? Where
yes, that's an English farm actually.
Oh, is it English? Yes.
Yeah.
Where it was an organic farm. The emissions per kilogram of milk was higher. What sort of implications does that have for this type of a dairy production system, given that, okay, look, there are other environmental benefits arising from organic farming, but is that something that we should be looking at more closely?
Yeah, so it's organic farming. Generally, you have a lower milk output with that, and I guess that's why it's really important to look at our environmental sustainability from different perspectives. So I've only looked at it here per kilo of milk, and obviously if you're producing less milk, it's going to drive up your carbon footprint. So if we flip that then and looked at it from a per hectare basis, that farm would actually be one of the lowest. So, in terms of a per hectare basis, and that's really important as well, because if we're considering our land as, we need our land to reach our targets. We need it for sequestration and renewable energy technologies. That's also an important metric to look at as well. So the good thing about LCA is we can take into account all of that, and once we get all those other impact categories in there as well, we can get a much fuller picture.
We had a question there just in relation to the baseline years that were chosen for each of the countries. Presumably they're appointed by the national or regional governments, those baseline years. Is there a reason for that, or is it just a national decision for those countries?
Yeah, regions? I guess it's a national decision. It also depends on the trends of greenhouse gas emissions in each of those countries. So obviously in Ireland, we had a peak then, so we targeted, we made our targets based on that year. And I don't think that the trends in those other regions are as steep as what it was in Ireland.
Yeah, because the reductions are quite different, aren't they? Compared to the Irish. Looking there, comparing, it was 22 to 30 in Ireland, through to 11% in Portugal.
Yeah, that's quite reflective, really, of the profiles that I showed in the previous slide, where we could see the proportion of emissions coming from agriculture, and Ireland having the biggest. We'd have the biggest target naturally.
Well, it's very clear the type of measurement is so important, isn't it? How we actually present the carbon emissions from the sector. Pat, some really insightful questions coming through from our audience. And just before we go to the questions, I want to say a special welcome to all of our foreign audience this morning. We have visitors from all 5 countries that are represented in the study. So you're very welcome to the Signpost webinar this morning. Pat?
Yeah, there's I suppose one question here sticks out. Is there more potential for house systems to become more carbon efficient with the development of additives like tree-nop and methane inhibitor and the covering of stores? I suppose the question is it going to be harder for the grazing-based systems to get those reductions?
Okay, so first of all, yeah, with the confinement systems or the house systems, it definitely is possible, and we've seen that with the slide of the different individual farms, that confinement systems can be just as low as the grazing systems. And there are some really good technologies out there, such as 3NOP, and we saw the difference covering slurry stores makes. And there's also, I know, for measures in Portugal and Spain and France about using anaerobic digesters, which can also further reduce their emissions from manure. And then the second part, then about the grazing systems. Yeah, see, we could see from that profile what we really need to look at Solihead, where we're cutting out nitrogen completely. We can bring down our carbon footprint to 0.7. So there's clear areas there to work on
in both systems.
Yeah.
So there's a number of questions there around the whole issue of I suppose the pressure on farmers and the level of information and level of political pressure on farmers to reduce emissions. In Ireland, I suppose there's a huge awareness. Is the same level of awareness there in the other countries that you're dealing with?
Yeah, it's a hard question. I think I generally find, like, I'm not from Ireland, but being in Ireland, that I think most people are in touch with our farming community. So I know that I think that Irish people generally have a sense of the challenges facing farmers. And speaking to the partners and our work on the social aspects of the study, other partners definitely identified issues with this, I guess, negative image of farming. In Spain and Portugal and in the UK, there's definitely some issues there with consumer perception.
I think also the percentage of emissions from the agricultural sector in Ireland is probably, is higher than those other countries, has probably led to that as well. A question, Marion, around in all of the different measures you presented for each of the different countries, there was, say, nitrogen fertilizer was mentioned as a measure. Are there different approaches to that being taken in the different countries? For example, I know there's in Ireland there's a huge emphasis on the use of protected urea. Is that something that's being promoted in other countries, and are there other measures around nitrogen use reduction?
Yeah, I guess the first thing I'd say is I definitely noticed, like, in the data, that our Irish farmers were really the only ones using protected urea, not so much uptake in the other regions. The other regions, I think, in terms of fertilizer use, it's about maximizing the nitrogen when they do spread it. There's more arable land included in these farming systems, and making more use of their slurry. They tend to use more incorporation methods for slurry management, which we can make more use of our slurry for that nitrogen.
Thanks, Marion.
There's a question in there around the I suppose the level of mixed enterprises on the farms. I suppose in Ireland you probably have fairly dairy only enterprises. Are they generally mixed enterprises? Is there a lot of tillage involved in the enterprises in the other countries? You talked about Portugal, where there are confinement units which may not have very much land available to them, but importing and exporting all of their feeds.
Yeah, so I guess the aim when we were choosing the farms was to choose dairy enterprises only. So yeah, we tried to stick to the dairy specific enterprises. But yeah, there's no doubt that these other regions rely on those arable farms.
There's a good few questions coming in relation to the appropriateness of the metrics. I don't think anybody's asking questions about the appropriateness of the per output, but asking questions about should we be considering more our emissions per hectare and using other metrics. What's the most, I suppose, balanced way to get a balanced view of our emissions?
That's a hard one, isn't it? Yeah, so like James said earlier, there's definitely pros and cons to expressing the carbon footprint on a per kilo of milk, but there's also, like as I said, huge importance on expressing it per hectare. You know, especially when we look at it from a national perspective, we have national targets to meet. How we use our land is very crucial. So I guess, I don't know, identifying the best metric, I think we have to account for both, because you know, at the same time we also have to feed a growing population. Yeah,
I think that there's a clear international consensus that the starting point is per unit of product, per litre of milk, and that's really what we presented today. But it is possible to look at emissions from a number of different perspectives. Of course, the only thing that has to be borne in mind is that any practice that we implement, and that's really what this project is about, is identifying practices. Generally speaking, if we identify better practices, they're going to lower emissions one way or the other, no matter how we express the units. And just going back up to an earlier question, when we set up this project, we specifically selected specialized dairy farms. And just to clarify, there's a lot of tillage on some of these dairy farms, but they're tillage for like maize, for example, for animal production, for the dairy production. They're not tillage they're not cash crops, for example. Like, these are specialized dairy farms.
There's a question, and you mentioned, rather than getting into detail on the economics, I suppose a question there in relation to whether or not there was a relationship between the carbon footprint and the profitability of these farms. Are the ones that are most carbon efficient generally the most profitable, or which way does that relationship go?
Mm-hmm. We haven't yet gotten all the data for that, so it's still to be evaluated, but maybe if you invite me back, I'll talk about that later.
Okay, in terms of the imported forages, there's a question there as to how you go about calculating the carbon footprint of the imported forages, and I suppose of the imported concentrates as well.
So there's databases that we use for getting emission factors for each of those concentrate ingredients, each of those rations, and same for the forages. And we also take into account where they're coming from. You know, for example, an Irish farm is not getting the barley the same place as a farm in Spain, for example. You know, it's different locations, so we take into account all of that, and we rely on databases and local sources for that.
Yeah, there's just I suppose a comment here is it looks like buying in forage has an advantage in terms of lowering the footprint, especially if the forage is in the form of maize. Does that stand up?
Buying in forage as an advantage in terms of maize, I wouldn't say so. Like, it's I don't know how that stands up really. Like, yeah, if we look back to our emissions profile again, you know, our mixed or confinement systems were the regions, I guess the systems buying in a lot of the forage. So, and they tended to have higher footprints.
There's a fair amount of noise in the data around that, but it's quite clear, I think, that locally produced, if you can produce your feed on farm, pasture-based systems, for example, there's a clear trend in the data that locally produced feed for the livestock on the farm gives a lower emissions.
There's a question there, Marion, firstly starting off by saying very clear and interesting presentation, thank you. Could you explain what you mean by human edible feed conversion and how do you do that? And I know you mentioned that there was some work being done on that, or maybe are there any indications or early results on that side of things?
Yeah, so I guess maybe the simplest way to explain it is we want to know how much of the feed that we're giving to the cows is actually potentially edible from humans for humans. And grass, for example, we can't eat grass. So the human edible proportion of that would be 0. And I guess we assess, that's how we assess the fraction of human edible feed. And then we look at that in relation to the kilo of output. So the kilo of milk, for example.
So you're looking at the concentrates or grain that could potentially go into a human diet. That wouldn't enter the system as such, or would come into that calculation.
Yeah, so yeah, cereals tend to have higher human edible proportions. Yeah.
Okay, so imagine there is quite a difference then between the different types of the indoor systems versus the outdoor systems. Why, James, is that figure so important, that human edible feed conversion, or is there more emphasis being put on this?
Both, if we look at the question of land use and what land is used for and what it can be used for, and like in Ireland, we've a long tradition of pasture-based systems, and that's all down to the suitability or relatively wet climate. It's interesting that within the Atlantic area, we don't have exceptionally high rainfall. We've much lower evapotranspiration, much damper climate, wetter soils. And really, a lot of our land, particularly in the west of Ireland, is more suited for grass production than anything else. And you could say that there's limitations around what it might be used for. Whereas, say, in some regions, for example, that land could equally be used for production of human food that's used for humans, say, you could say wheat, for example, which could be used for animal feed, or could also be used for human consumption. So I guess that's really the question, and it's there's a lot of concern about the environmental impact of agriculture, carbon footprint, and I guess there is that land use question as well. How do we use our land? And then there's other questions that come into that, like offsetting, for example. But if we need to produce food, we have a growing global population. Like if land is best suited for grass production, can't be used for human food production, that has to influence the argument or that debate.
It really is fundamental, isn't it? That low, what is the lowest environmental footprint that can be achieved with food production? Pat, I have a question for you, if I may. Pat, there's a question here in relation to a carbon calculator for use on Irish farms. What sort of work is happening there to try and help Irish farmers to understand their own carbon footprint?
Yeah, I suppose there's a number of systems in various stages of development. We would have had the Carbon Navigator before, which was more focused on practice change, and there's work ongoing, I suppose, by Board Bia in looking at farms that are part of the quality assurance scheme and coming up with calculations of the carbon footprint there. And those, I suppose, schemes are improving in accuracy all the time as we get more and more information and better modeling of the relationships between various inputs and various outputs, and get better information. And then on the other side, in terms of planning tools. We're currently working with the Signpost farms, looking at practice adoption of a whole series of practices at farm level, assessing the level of adoption, and looking at influencing the uptake of the measures that are being identified as having the most impact. So quite a bit of work ongoing, and hopefully quite a bit of product will be in place over the next couple of years.
Great, thanks, Pat. Because I mean, I know that there is a lot of effort, and I'm sure, Marion, you have discovered that, trying to actually get an accurate picture of the carbon footprint of a farm, and how far do you go? Where does life cycle analysis itself is quite an in-depth process when you're looking back the chain, the supply chain, and so forth. How realistic is it for every farmer to have an accurate picture of their carbon footprint, or should we be looking at more proxies? And maybe James, you want to come in on this one as well?
That's what I'd say about that is, for the type of study we're doing, we went for very intensive data collection, really intensive, get a very accurate, scientifically, it's scientifically backed up. It's we'll send it for peer review, and it'll be published, and it's a very solid figure, and that's for the purposes we're using it for, to look at practices and identify practices. And if we want to identify practices, we need to know that they actually deliver what they say they will. So we need a level of accuracy that you might not necessarily need if you were, say, a farmer and you wanted to ask a question. I want to lower my carbon footprint. What are the practices that I might implement? Now, carbon footprint that you might actually calculate mightn't be as accurate, but still it will identify the practices on your farm that you could implement. If you understand, you might need the same level of resolution that we're using. And it goes back to the earlier question about metrics. Again, if generally speaking, we know what we need to do, we just need to move in that direction in terms of lowering our carbon footprint.
Yeah, and I think there's a comment there that the level of data that you're looking at is not really practical on all farms, and that's why this type of research is so important, that it actually gives us the level of insight that's just not possible to do on an individual farm basis. There's another question there in relation to the degree to which you took on board a proportion of the greenhouse gas emissions to go to the meat production, which is there on those farms inevitably as well.
Okay, so I guess that's a question of allocation, and we used biological allocation for that. So there's an equation that we use that's recommended by the International Dairy Federation, where we take into account the kilos of meat and milk produced, and allocate the emissions based on that.
Okay, there's a question here, and I know you dealt with it, but I suppose it's just to clarify. There's a point being made that it's surprising that given the methane emissions is expected to be higher higher on grazing than concentrates, that you're getting very similar figures for the overall methane proportion of the greenhouse gas emissions per kilogram of product.
Yeah, we don't expect that to change too much. But we know, like, things like how many replacements we're keeping on farm will definitely affect that. Our diet, our productivity. Then when we're looking at our carbon footprint per kilo of milk, how efficient are our cows will make a difference to that as well.
There's an interesting, just a clarification, I guess, where you're looking at the carbon footprint. We're looking at carbon equivalents here, and presuming you're looking at all of the different gases that are being emitted, or carbon emissions from these farms. Maybe just could you tell us, Marion, about the individual aspects of that?
Yeah. So I don't want to go into too much, but it's mainly 3 greenhouse gases that we look at when we're looking at dairy farm emissions. So the first one being methane, and then nitrous oxide as well, which is the most potent. So it goes nitrous oxide, methane, and then carbon dioxide. And carbon dioxide is the gas that we use as our base. We use carbon dioxide equivalents, really.
Next week, we're going to be speaking about ammonia emissions, but was that aspect looked at during the study?
Yes, it was. And I guess for the short space of time that we had to talk, we didn't go into it too much, but that's definitely looked at as well.
There's a question there in relation to clover. Is the only impact of clover on greenhouse gas emissions the reduction in nitrogen, or are there other factors of a high proportion of clover in the diet?
So clover in the diet, I guess we're looking at the protein content then, and more nitrogen going through the animal means more nitrogen excreted, but we don't expect that to make too much of a difference in terms of our gaseous emissions. But that more nitrogen goes in, more nitrogen comes out, and we get gaseous emissions from that. So yeah. James, do you have anything further to add?
Yeah, I think it's the manufacture of the fertilizer, and also the emissions following the application of the fertilizer. Nitrous oxide emissions, as Marion said, it's a very potent greenhouse gas. And even say if we look in Sorley, we lose a very small amount of our nitrogen as nitrous oxide. The fact that it's such a high global warming potential, it has a big impact at farm level. I suppose part of that way you might look at that question is how clover might impact on methane emissions, and I guess there's some work being done on that. But as things stand, the approach we're taking is that it's having no positive impact, but research might show that there's something there as well. In terms of if there's more clover in the diet, it could impact on the methane emissions from the enteric fermentation. But I think that's work in progress.
Okay, we're coming up on time. It's hard to believe we're 10:30 already. Marion and James, thank you so much for joining us this week, and congratulations on really fantastic piece of research here that will inform the discussions around how we measure carbon emissions from farms, and to all the partners involved in the project as well. It's really, I'm sure it was a long process, as you said. There was a lot of detailed analysis required, but I think it's fantastic to be able to present those findings today. So well done on that. Thank you to Yvonne Maher in the background for helping us today with the technical aspects, and Pat for assisting with the questions, and also to Andy Boland, who is our series producer. And a reminder that today's session is available, will be available shortly on the Teagasc YouTube channel, as well as the podcast platform and our website with the presentation itself. We had over 400 participants today, so it was obviously a topic of interest, and we'll be dealing with more of this area over the next number of weeks and months. But next week we'll be joined by Dr. Dominica Kroll and Dr. David Keelahan from Teagasc, who'll be discussing ammonia emissions and impacts, and also some solutions being offered during that presentation. So do join us next Friday at 9:30 for the Signpost webinar. So we will leave it at that. Thanks again, Marion and James and Pat, and we will see everyone next week at the same time. You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.